We are going to look at one domain of dynamic programming, which is tiling problem. We have seen it before. This is nothing but a tiling problem. You'll be having a floor, you'll be having tiles of different sizes. You just need to count the arrangements, right? There's another example. Now let's come to a typical coding problem of tiling, what it will look like. Now input and output will look something like this. You'll be having a floor of given size and you'll be having tiles of different sizes. We just need to count number of ways to arrange those tiles in the given floor in the given matrix. Let's look one example to understand it better. Suppose if you have a floor of size 1 cross n, it's a 1D array kind of, and you have two types of tiles, one red, another blue. And of course, we have infinity amount of tiles, that means applies infinity. Just let's see how many ways are there to count it. Again, the question template is similar. Matrix is given, tiles is given. Now, if there is only one box, right? If there was only one box, the answer here will be simple. You can just place a red tile, not blue. Answer will be 1. If the floor size is 2, what will be number of ways? Number of ways here will be 2. You can either place 2 red or just 1 blue. Now let's expand the problem. If the floor size is 5, number of arrangements is how many? I want you to pause the video for a while and think about it. Now here, one way is clear that we can place all red tiles, and there are 7 other ways making total as 8. And you need to focus here. These two have same number of blue and red tiles, but arrangement is different. We'll still count it as different, right? Now, let's try to nail this problem with a little recursive thinking, and let's see what will be. If this is the problem we have 5 size left. If I ask you, just focus on one size for now, first cell for now. If you have to fill that, how many ways do we have? We have 2 ways. Either we can put a red tile or we can place a blue tile. If you put red, we are left with 4 space. If you put blue, we are left with 3 space. Let's continue this. If you have to fill this and this, let's see how many ways we have, right? Here, if you want to fill this, you can place a red tile making the space left 2. You can put a blue making the space left 1. Now we have to focus on one thing. Here, can we place a blue tile? Can we place a blue tile here? Answer for that is no. If you try to place it, this is what the arrangement will turn out to be. If you put red here, the entire floor is occupied. But if you try to put blue there, you want one more extra space, which you don't have. That means here, we can say we have one valid arrangement. Here we don't. Now this part, it should be very clear to you that we are supposed to fill either red or blue. Now if you try to compress it to sub-problem, let's see what it will be like. We know f of n is a function which we are trying to find. And what is that? Number of ways to arrange tiles for n-sized array. If you try to expand it, we are clear that f of n has 2 types of arrangements possible. One, you can put a red tile. Another, you can place a blue tile. And of course, we have came up with kind of base cases also for this, which is if n became 0 while doing recursion. That means we have found one possible arrangement. But if n became less than 0, the arrangement was invalid, right? Now for this, if you try to visualize how recursion will go, let's say f of 5 will call f of 4 by placing a red tile, and I'm letting the animation play now. Now f of 0 we handle as a base case. Whenever it is 0, we know answer is 1, and f of 1 answer will be 1. But from f of 2, we can also place a blue tile, making it look something like this. Now this is what the entire flow will look like for f of 5. Even though we have found the answer as 8, which is correct, but there is a small problem here. What is the problem? Problem is, same size problems we are trying to find multiple times, like f of 1 here, f of 2 here, f of 3 here. This case is nothing but overlapping subproblems which will be solved by dynamic programming. What is overlapping subproblems? We are computing same size problem answer multiple times, many times. How will dynamic programming help? It will just say memorize the already computed answer, right? store already computed answer and reuse it. Yes, reuse it. Now, this is what the state is. When you talk about DP, there are two important things. One is state and there is transition. State is define your problem in terms of a function, which we did. Transition is just expand this function for us, which is this one. There will be one small base case also for this recursive code, which you already found, which are these. Now let's try to write recursive code for this, which will look something like this. We just wrote the base cases. We just returned like it is a Fibonacci series, and we have the answer now. But here the problem is time complexity. We have seen in the recursive flow that same problem are being computed many times, which is a problem. Now to come up with this, we said memorize it. We have to use just one simple thing, a DP array, and assuming it is filled with -1s. Why -1? -1 actually represent, hey, it is not computed yet. Yes. Now what are we doing? It is the same recursive function that we wrote earlier, just that before we make the recursive call, we are checking if it is already computed, reuse it. And if you're computing for the first time, just store it. Just these two simple things make the time complexity go from 2 power n to just n, because we are avoiding recomputation here, right? Now this is about recursion, which we call as top-down approach. There is another way of implementing the same code, which is bottom-up. Let's see with an example. I'm letting the animation play. This is saying if you have an n equal to 3, we can reuse previous two members to get the answer, right? And so on. Now this, if you have to convert it to code, it is very simple. Instead of using recursion, we are just going to use iteration loops and we are done. As simple as that. And this also time complexity is O of n. Now let's move on to the next question. Let's say we are bringing one more type of tile, which is a purple tile. Okay, the size is also same. It is 1 cross 1 only. Now these are three types of tiles. If the size is only 1, if the floor size is only 1, number of ways we have now will not be 1, is that right? Number of ways will be 2. You can place a purple tile and a red tile. If it is 2, if the floor size is 2, how many ways do we have? I want you to pause the video for a while and think about it. Okay, in this number of ways will be 5. We can either place both red, purple, purple, red, both purple and one blue. Of course, it is just one blue. Now, if you think of the state is same, is that right? F of n only we have to find. But what we have to think about is a transition, right? Now for transition, if you think in the same perspective, instead of worrying about entire problem, let's just focus how to fill this one particular cell. To fill this one particular cell, now we have 3 ways. Yes, we have 3 ways. We can put a red tile, purple tile or a blue tile. It should be kind of clear to you what the transition now will be. Transition now will be n minus 1 plus n minus 1 plus n minus 2. This is for placing a red tile. This is for placing a purple tile. This is for placing a blue tile. And in this also, base cases will not change. We can trim down a transition to this. Now we can use either memoization or tabulation. Memoization simply means recursion here. This means iteration.